Hello everyone, these are a few questions on capacitors. First question is we have a 30 microfarad capacitor is charged to an 80 volt power supply. The power supply is then removed and the charged capacitor then connected across an initially uncharged capacitor of unknown capacitance C. If the final potential difference across the 30 microfarad capacitor is equal to 20 volt, determine value of C. Okay, so let's do a simple sketch to explain things. So initially we have one capacitor, let's call it C1, and was connected to a power supply, let's call it V initial or V naught. So this is C1 and this is V naught. Okay. Then we remove the power supply and connected C1 into another capacitor. So this is C1 into another capacitor, let's call it C2, which equal to C. It's unknown. And the question says the potential difference after we did this rewiring, the potential difference across C1, so the potential difference across these 2 points equal to 20 volt. So we need to find the value of C. So the first thing is we need to find the initial charge. The reason is this is an isolated system. So initial charge in the system is equal to the final charge in the system. System before just consists of a power supply and C1. Afterward, the system consists of C1 and C2. So here we could find the Q initial, which will be equal to C1V initial. In this case, this is equal to, so we have 13 in micro, so 10 to the power minus 6. And we have power supply, initial power supply is 80. I'm going to just keep everything in micro. So 3 times 8 is equal to 24, 0, 0. And I'm going to say this is a micro column. Okay. And this is equal to Q final. Q final means this is the Q that will be on this capacitor and on this capacitor, both of them. Okay. Okay, so there is another info. The question tells us that this capacitor, we know the voltage across it and we know the capacitance of it. So we could, from this, we could find the voltage, the charge on C1. So it's Q1 final is equal to C1 V final. Okay, so that's equal to C1 is 30 micro, so 10 to the power minus 6, and the V is equal to 20. So the answer, again, I'm going to keep it as micro, so it's 600 micro coulomb. Okay, now let's look at this and look at this. So initially C1 had 2,400 microcoulomb. And after rewiring in C1 with C2, the leftover charge on C1 was equal to 600. So the rest has to be on C2. So we could say now, because Q initial is equal to Q final, Q2 final is equal to Q initial, total I mean, minus Q1 final. So basically we have 2,400 minus 600 is equal to 1800 micro, right? Micro coulomb. So this will be the charge. This will be the charge that's on capacitor C2. Okay. This will be the charge that will be accumulated on capacitor on each plate of capacitor C2. Okay. Now we know the voltage. Sorry, we know the charge. And we know the voltage as well, because this point is the same as that point. And that point is the same as this point. So which that tells us the 20 volt also will be across the C2. So V across the capacitor 2 is equal to 20 volt. That simply tells us that C, or C2, let's say, is equal to Q2 divided by V2. So is equal to 1/8. It's micro, 10 to the power minus 6, and V2 was or is 20. So this with that, this is with this, it should be 289. 90 microfarad. Okay, so it looks like this is the answer. This is the answer. Okay. Okay. Next question. Next question, we have a few capacitors. 4 capacitors are connected as shown in the figure. Let C is equal to 12 microfarad. Find the equivalent capacitance between point A and B. So here point A and point B. Okay. And then let's do part A and then we're going to talk about part B. So usually when I solve this kind of questions, to avoid just putting numbers inside the equation, I'm going to just say this is C1, this is C2, this is C3, this is C4. Okay. So C1, C2 series, so basically C1, C2 is equal to C1, C2, C1 plus C2, right? So in that case, we have the value of 12 times 3 divided by 12 plus 3. I think the answer is equal to, 2.4. Oh, please double check my answers. Okay, this is 2.4 microfarad. Now, this C1, C2, it's equivalent of capacitors C1, C2. It's in parallel with C3. So C1 to 3, remember this is equal to C1, 2. Let's just write it in a nicer way. Is equal to C1, 2 plus C3. So it's 2.4 plus 6 simply is equal to 8.4 micro, right? It's microfarad. Now C equivalent, it's a C123 series with C4, so it's equal to C123 times C4, C123 plus C4. So we have 8.4 times 20 divided by 8.4 plus 20. Equal to, if I am right in using my calculator, is equal to 5.92 microfarad. Please double check. Okay, so this is part A. This is part A. Okay. Part B, calculate the charge on each capacitor taking VAB is equal to 20 volt. So think about it that we have a power supply connected here. Okay, it's not shown, but this is what should be the case. Okay, so this point is A, this point is B. I'm going to also name another point because I'm going to need it just to make things. I'm going to call this as point C. So I have A, C, B. Okay. So usually in this kind of questions, in order to find charge on each capacitor, you're going to use this equation. Charge in general is equal to C multiplied by delta V. Okay, so if you go to C1, okay, you know the value of C1, but you don't know the potential difference across it, so it's not easy to directly find, just go to C1 or C2 or C3. So the best way is to, kind of go backwards. So find the total capacitance, which we have. We know the total voltage. Let's find the total Q. So that's what I'm going to do, and then I'm going to go, I'm going to go backwards. Okay. So Q final or Q total, let's say, Q total is equal to C equivalent, means C total, multiplied by delta V, which we know the answer for it. So in this case, C, it's this volume, multiplied by 20 volt. So this equal to 118, actually 118.3. This is microcoulomb. Okay, but because C3 and the combination of C1 to 3 are in series, so the Q total in fact is equal to Q4. So we already know Q4 is equal to 118.3 microcoulomb. Good. So we're done with one of them. Okay. Now, from here and beyond, there are different ways. At least there are two ways to continue. One way, you could find the potential difference across C1, 2, 3, and then potential difference will be the same for C3 and the same for both C1, C2 combined. Or you could do the following. Another way is try to find the voltage on C4. Okay, so if you know the voltage of C4, so this is V4. If we know V4, we know the total voltage, so the voltage across AC is equal to 20 volt minus V4. So let's do that. So I'm going to say V4 is equal to Q4 divided by C4. Okay. So Q4 is 118 minus 3. It's in micro, right? So micro column. C4 is 20 micro column. Let's see what will be the answer. 118.3 divided by 20, 5.9. 5.9. 5.92. That tells us that VAC is equal to VAB minus V4, right? Okay, so this equal to, what was the total? It's 20 minus 5.92. So minus 20 here, it's 14.08, let's say 14.8. So that's VAB. VAB is equal to 14.1 voltage. But remember that. VAB actually is V3. So which means V3 is equal to 14.1 volt, and V12, both of them together, is equal to 14.1 volt. Okay, so this is going to help me. If I know V3, I know C3 is going to help me to find Q3. So that tells us that Q3 is equal to C3 V3. So C3 V3 equals to, C3 is 6, 10 to the power minus 6. And we have 14.1 equal to, so 6 times 14.1, 84.6, 84.6, 84.6. Does this make sense? Yeah, 84.6, this is micro column. Okay. So the last part is to find the second part. We have V12, we have C12, we could find Q12. So Q12 is equal to C12 times V12 equal to, C12 was 8.4, and voltage is 14.1, so equal to 8.4 times 14.1, 118. No, something is wrong. C12 is, I think I did a mistake. C12 is not 8.4. C12 actually is 2.4. So this is a typo. It's 2.4. Okay. Now 2.4 times 14.1, 33.8. So this equal to 33.8 micro column. But remember, C12 are in series. That means Q1 equal to Q2 and is equal to this number. Okay? That should be the final answer. Okay? So I have next question. Here we have the circuit in the figure below consists of two identical parallel metal plates connected to identical metal springs, a switch, and a 146 volt battery. with the switch open, the plates are uncharged and are separated by a distance equal to d. So we have d value. Okay. And have a capacitance C equal to 2 microfarad. When the switch is closed, the distance between the plates decreases by a factor of 0.5. By a factor of 0.5. Okay. Question part A, I mean, how much charge collects on each plate? How much charge collects on each plate? And B, what's the spring constant for each plate? So we have the following case. We have a capacitance, 2 plates. When the switch is closed, this plate will move, let's say here, and this plate will move here. Okay, so a few things. D will change to, I'm going to call it D prime. Okay. And D prime is equal to 7.5 mil divided by 2, so it's equal to 3, let's just get the number, 375 mil. Okay, so actually this is D. This is D prime, I should say, and this is D. Okay, so according to this equation, let's put it here. C is equal to epsilon naught, this is for para plate, A divided by D. So D goes to half, means C has to double, right? So the new C also will be double. So C prime is equal to 2C, which our C is 2 micro, so this we have 4 micro farad. Okay, 4 microfarad. Okay. So part A should be easy now. Q is equal to CV, actually C prime delta V, right? Because we have C prime now. So is equal to 4 in micro, multiplied by voltage is 146. So the answer is 5. Always double check my answers, please. Microcoulomb. Okay. This is done. Second part. What is the spring constant for each spring? So let's think about plate. Left one or right one doesn't matter, right? So each plate is attached to a spring, right? So if you displace a spring from its equilibrium position, a force from the spring will be applied on the object, in this case the plate, and the value of the force is equal to, or the magnitude is equal to Kx. X is the displacement value from its equilibrium of the spring. Okay. So I'm going to take the left plate. So let's focus on the left plate. So I consider the left plate. There will be 2 forces affecting on it, right? One force will move the plate to the right, which is the electric force, and one force will try to bring it back to its equilibrium. When I say equilibrium, this is the position of the equilibrium of the plate, means the spring will be unstretched. So this is Kx. Okay. So we have now Kx is equal to F, but F is electrical force equal to QE. Okay. Now here is important to think about electric field produced by one plate is actually half of the total of electric field, right? It's half of the value. So we have to think about this half. So we need electric field, whatever the value, we need to divide by 2. Because each plate contributes to half of the electric field, which is located between the 2 plates. Okay, so first of all, what is X? Well, X actually is this distance, right? Is that distance, which equals to D minus D prime divided by 2. So X is equal to D minus D prime divided by 2. Okay, what's E? E, we could relate E to the potential difference. It's between the 2 plates. We know, let's put the equation here. We know delta V as a magnitude is equal to E multiplied by D. But D in our case actually is D prime, right? D prime. So actually E is equal to delta V divided by D prime. Now, notice here, I'm going to put 2, divide by 2. Because the electric field, the contribution of left plate to the electric field is half, right? Each plate contributes to half of the electric field. So I could plug the numbers here from this equation, K should be equal to QE. E is delta V. This is 2D prime. This is E. QE divided by K. K is D minus D prime. Divide by 2, so the 2 will be here. This 2 will be cancelled out by that. Equal to Q delta V. Here, what should we do here? Just keep it as is. So it's equal to, because we have the values, or you could just multiply them, but just keep it like that. Okay. So that should give us the value of K in Newton per meter. Okay, this question is, we have two capacitors, C1 6.5 microfarad and C2 2.5 microfarad are charged as a parallel combination across 250 volt battery. The capacitors are disconnected from the battery and from each other. They are then connected positive plate to negative plate and negative plate to positive plate. The question asks, want us to calculate the resulting charge on each capacitor. So first of all, let's just do some sketch to understand the equation. So we have two capacitors. Notice that C1 is larger than C2, right? So if they get charged with the same connected to the same battery, the amount of charge accumulated on C1 will be larger because Q is equal to C delta V, right? So we have the following situation. We have C1, C2 connected in parallel to a battery like that, right? Okay, and then disconnected. So you know, because C1, C2, V initial. So let's say we have too many positives here, negatives here. Because C1 is larger than C2, I'm going to put maybe just two of those positive, negative, just to indicate that the value of the charge more accumulated on plates of C1, C2 because C1 is larger than C2. So now we're going to do this. We're going to take this capacitor and we're going to try to connect it to this capacitor. Let's not connect it yet. So now we have too many positives here. But you have negative, negative, positive, positive. So we know what's going to happen if you connect these two points together, right? What's going to happen is there would be a redistribution of charge because C1 is larger than C2, or maybe I should say this is C1 and this is C2. We expect that the upper plates for both of them will be positive just because C1 is larger than C2. So at the end we're going to have things like that, maybe, not maybe for sure, but still the amount of charge less on C2 because it's still a smaller capacitor. So this is C1, this is C2. Okay? So notice we have positive, positive, but here we have negative, negative because the question wants us to do this. So the basic idea here, these are isolated systems, right? So what we conserve in this case charge. So charge is conserved, it's unchanged. So we say Q final is equal to Q initial. Final, I mean this is final and this initial. Let's think about it, okay? So Q final here. So Q is equal, oops, what happened here? Q initial. Q final is equal to, so Q is equal to CV is equal to C1 V final. V final means how much voltage we have here and how much voltage we have across it, plus C2 V final. Notice that I say plus here because we have plus sign, we have plus sign here, okay? Equal to Q initial, now let's talk about that. Q initial is equal to CV and other CV, so it's equal to C1 V initial, it's this one, but minus, because we have negative here, so I took the upper plate from the left and I should take upper plate from the right. If you do the solution, you take the lower one and the lower one, the answer simply it will be will be the same, but the negative will simply go to the first term, not to the second term. So this is equal to C2 V initial. Okay, so that simply tells us that V final equals to C1 minus C2 divided by C1 plus C2 multiplied by V initial. Okay. So V final would be 6.5 minus 2.55. This is in micro. Remember, this is in micro. But I have the same two value you added, so micro with micro will cancel out. Multiplied by V initial is 250 equal, I don't want to calculate this, equal to some voltage. But it will be smaller than 250 volt because this is smaller than one. Okay. Okay, so 220 volts, this is V final. So then now it's easy, I could find Q1 final equal to C1 multiplied by V final, which is this value. And Q2 final is equal to C2 multiplied by V final, which is this value. And you could double check things. This quantity plus this quantity should be equal to Q initial, which can be found simply.